Hi everyone, I hope you are doing well. Welcome to this video and welcome to my channel. In this video, we are going to learn how to calculate least common multiples of two numbers or something which we call it LCM. In fact, by the end of this video, you will be able to solve examples that you can see in the first slide. First of all, we need to get familiar with the definition of multiples. It's really simple and you probably know that the result of multiplying the number that we want to write multiples by a natural number will be its multiples. If you do not get the definition, don't worry, we are going to solve examples as always. We have 8 and now we want to write multiples of 8. So we are going to start from 1. 8 times 1 will be 8. 8 times 2 will be 16. 8 times 3, 24. 8 times 4, 32. 8 times 5, 40. And I can continue that as long as I want to. So these are multiples of 8. And I can write multiples of 10. 10 times 1, I always must start from 1. 10. 10 times 2, 20. 10 times 3, 30. 10 times 4, 40. 10 times 5, 50, and so on. These are multiples of 10. For calculating LCM, there are two methods. The first method that I do not suggest you at all is providing a multiple list for both of the numbers. Yes, it is simple, but it is time consuming and possibility of making mistake is really high. But I have to mention this method. For example, I want to write LCM of 4 and 12. So I need to write multiples of both of them. For 4, 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. And I can continue as long as I want to. For 12, 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. 12 times 4 is 48. Okay, now can you please tell me the least common multiple between these two numbers? Of course, in the multiples of 4, I have 12, and in multiples of 12, I have 12 as well, and this is the least common one. So LCM of 4 and 12 will be 12. Sometimes some students they think they are clever. They multiply 4 and 12 and they are going to reach 48. And they say this is LCM. No, first of all, they are not clever at all. Second of all, multiplying the two numbers is going to give you a common multiple. Okay, it's totally acceptable. But all the time, it's not going to give you least common multiple. So I strongly suggest you not to do that. Now I want to write LCM of 6 and 8 with the bad method that I just introduced to you. 6 times 1, 6. 6 times 2, 12. 6 times 3, 18. 6 times 4, 24. 6 times 5, 30. 36. And so on. For 8, 8 times 1, 8. 8 times 2, 16. 8 times 3, 24. 8 times 4, 32. 8 times 5, 40. Okay, what is the least common multiple between these two numbers? As you can see, 24 is the least common multiple, or some of the references prefer to call it lowest common multiple. So LCM of 6 and 8 will be 24. Let's go for the method that I love the most. It is really simple. We are going to use prime factorization method, but before watching this part, I strongly suggest you to stop the video and watch the video which titled how to calculate prime factorization of two numbers, because if you don't know how to calculate prime factorization of two numbers, you are not going to be able to use this method. What should we do? First, we must write prime factors of two numbers. Then LCM can be calculated by this formula. Common prime factors with the maximum powers multiply to uncommon prime factors with the main power. At the beginning, you may think that this method is really hard, but after solving examples, you will realize that this method is really simple. But I strongly suggest you to stop the video and watch the video title, How to Calculate Prime Factorization of Two Numbers. I'm going to put the link in the description. Here I want to calculate LCM of 32 and 72. I'm going to start with 32. Do you know any prime number that I can divide 32 to that number? Yes, of course, it is 2. If I divide by 2, the answer will be 16. Now, do you know any prime number that I can divide 16 to that number? Of course, again, 2. The answer will be 8. Again, I can apply 2. I'm going to have 4. 2 comes again. I'm going to have 2, the beautiful 2 again. 1, when I reach 1, I must stop. Now I'm going to write for 72. Do you know any prime number that I can divide 72 to that? Yes, of course. I'm going to start with 2. I'm going to have 36. Again 2, 18 divided by 2. It's going to be 9. Here I must apply 3. 3 comes here. And finally 3 again. So if I want to write prime factors of 32, I can write, how many 2's do I have here? As you can see, I have 5 2's. So 2 to the power of 5. What about 72? I have 3 2's as you can see here and 2 3's. So 2 to the power of 3 times 3 to the power of 2. Now I want to calculate LCM. What should I do? As the formula says, I must write common factors. What is common factor between 72 and 32? As you can see, in 72 I have element of 2 and in 32 I have element of 2 again. So 2 is common prime factor. What is the maximum power of them? Here the power of 2 is 3 and here the power of 2 is 5. So I must use maximum power, which is 5. And I must multiply to uncommon prime factor. Do I have any uncommon prime factor? Yes, 3 here. So I must multiply to 3 with the main power. What is the power of 3? 2, of course. So LCM will be 2 to the power of 5 will be 32 times 9. I'm sorry, times 9, which is equal to 288. Let's solve the next example. Again, I'm going to start from 18. Do I know any prime number that I can divide 18 to that? Of course, 2, 9. Do I know any prime number that I can divide 9? Yes, 3. 3 again. I must divide by 3 and I reach to the 1. When I reach to the 1, I must stop. 120, as I told you in the video of the how to calculate prime factorization of two numbers, when you have 0 at the end, you can apply 2 and 5, then drop the 0. So I drop the 0, I'm going to have 12. I divide by 2, I have 6. Again 2, 3, and divided by 3, 1. When I reach 1, I must stop. So for 18, when I want to write prime factorization, I have 1, 2 as you can see. So 2 to the power of 1 times, and I have 2 3's. 3 to the power of 2. And for 120, as you can see, I have 1, 2, 3. 3 2's. So 2 to the power of 3 times, how many 3's do I have? 1. I'm sorry. How many 3's do I have? I have 1 3 and I have 1 5. If I want to calculate LCM, as the formula says, common factors with the highest power, here I have 2 and I have 2 here as well. So I must write 2. Which one is the highest power here? The power of 2 is 3. But here the power of 2 is 1. So 3 is the highest power. And again, 3 is common between these two. So with the highest power. The power of 3 here is 2. The power of 3 here is 1. So I must write 2. And multiply to uncommon prime factor. Do I have any uncommon prime factor? Yes, this 5. So I must multiply with 5 with the main power. The power of 5 here is 1. So LCM will be equal to 8 times 9 times 5 will be 360. And this is the LCM of 18 and 120. Let's solve one more example. Let me tell you this. You may think this method is difficult, but this method is really, really easy. It is because you have not seen the video titled How to Write Prime Factorization of Two Numbers. So stop the video and watch that video first. The link is in the description. So I'm going to write for 14. Do I have any prime number? Yes, 2, 7, 7, 1. When I reach to 1, I must stop. Then I have 21. Do I have any prime number? Beautiful, 3. 7 comes here. I can divide it by 7. The answer here will be 1 and we will stop. So for 14, I can write it as 2 times 7. And for 21, we have 3 times 7. So I must calculate LCM between these two numbers. The common prime factor between these two are 7. And the highest power, the power of 7 here is 1 and here is 1 as well. So we must consider 1. And do I have any uncommon factor? Yes, here I have 3 and here I have 2 and I must write both of them. Times 3 times 2. And the answer will be 42. Here you can find more examples and I strongly suggest you to solve them at home. If you have any question or if you wanted to share your answer, please feel free and write them in the comment box. I will try to answer them as soon as it was possible for me. Thank you for watching this video.